Kayaking has become a popular outdoor activity, especially in California, with our many rivers and hot weather. But have you ever considered the physics that go on behind the scenes to make sure you stay afloat? Hello all, today we're going to be learning about the physics of kayaking. To be completely honest, I have no idea why I chose this topic other than it sounded fun and it's been pretty hot lately. I will be investigating why kayaks float on water as well as why they are able to move when a paddle is used to propel them. To understand the fundamentals of kayaking and boating in general, we must learn a new term, Archimedes' principle. This states that any body completely or partially submerged in a fluid at rest is acted upon by an upward or buoyant force of the magnitude of which is equal to the weight of the fluid displaced by the body. Essentially, this means that an object in water will float as long as the gravitational force pulling it down is less than or equal to the force that is keeping it up. My kayak is able to float because the weight of my body in the boat pushing it down is still less than the weight of the water it is displacing. A good way to visualize the Archimedes principle is to place a cotton ball and a rock in a body of water. Here we can see that there is a clear difference in the way that the rock and the cotton ball behave when placed into a body of water. The rock sinks because it weighs more than the amount of water it displaces, while the cotton ball doesn't, even though the cotton ball and the rock are about the same size. Now we are able to understand why a boat or kayak floats, but still don't know how it moves when it is in the water. To understand this, we must revisit Newton's third law. This states that for every action, there is an equal and opposite reaction. In the case of kayaking, the paddle is placed in the water, which responds with an equal and opposite reaction. Since the paddle is attached to a body that is sitting in the kayak, that energy is transferred to the boat, which moves in the water. In this force diagram, my kayak is accelerating from a stop because the force of the thrust created from my paddle is more than the drag from the air resistance in the water. The equal and opposite reaction of the water against the tip of my paddle is what propels the kayak forward, and conversely, what could stop it if I place the paddle in the water and do not move it. Thank you for watching. I hope you were able to learn something from this short video. I had a lot of fun making it, and quite frankly, I learned a few things too. Oh! Oh my god, that was amazing.